So in this lecture, let's look at binary trees. So a binary tree is a tree which has at most two nodes, which means that a binary tree is a tree which has either 0, 1 or two nodes, right? It has either 0, 1 or two nodes. The child nodes are referred as the left child node and the right child node. For example, if this is A, then the child node is left child node is B and the right child node is C. So A has two child nodes, whereas B has 0 child node and C has 0 child nodes. Therefore, this tree is a binary tree, right? For example, let us see here itself where A is a binary tree. Why? Because A has 0 child nodes. A, A has one child node, whereas B has 0 child nodes. A has one child node called B, whereas B does not have any child nodes. Here I can say A, B, C. A has two child nodes, B has 0 child nodes, C has 0 child nodes. So B and C are child nodes of A, right? So this tree is a binary tree because each and every node has either 0, 1 or two child nodes. Here in this tree there is no a single child node. Therefore in this tree there are only 0 and 2 child nodes. Therefore this is also a binary tree. Is this a binary tree? Yes, this is a binary tree because A has one child node as we have seen and B has 0 child node. Now, is this a binary tree? No, this is a tree. This is not a binary tree. Why? Because A has 3 child nodes. So once a node has more than 2 child nodes, or once a node has neither 0 nor 1 nor 2 child nodes, then that tree is not a binary tree. Here A has 3 child nodes, B, C and D. Therefore this tree is not a binary tree. So a binary tree is a tree which has at most two child nodes, at most, at most means that it should have either 0, 1 or 2 child nodes only. It cannot have more than 2 child nodes. It cannot have more than 2 child nodes. The child nodes are referred to as left child node and the right child node. Here in this tree, the left child node is B and the right child node is C, and the root node is A, or A is the parent node. Now let us look at types of binary trees. There are various types of binary trees such as full binary tree, complete binary tree and a perfect binary tree. So what is a full binary tree? A full binary tree is a tree which has either 0 or 2 nodes, which means that it can have only 0 or 2. It cannot have a single child node. For example, if I say A is a full binary tree. A, B, this is not a full binary tree. Why? Because A has one child node, that is B. As the definition says, a full binary tree is a tree which has either 0 or 2. It cannot have a single child node. Therefore this is not a binary tree, not a full binary tree. Here A, B, C, this is a full binary tree. This is a full binary tree. Why? Because A has 2 child nodes and B has 0 child nodes and C has 0 child nodes. Therefore A has 2 child nodes, B has 0 child node and C has 0 child nodes. Here A has 0 child node. Therefore a full binary tree is a tree which has either 0 or 2, right? So here if I say like this, A, B, C, D, E, F, G, right? This is a full binary tree. Why? Because A has 2 child nodes, B and C. A has 2 child nodes, B and C. B has 2 child nodes, D and E. And C has 2 child nodes, F and G. And D, E, F, G have 0 child nodes. Therefore, every node in this binary tree has either 2 or 0 child nodes, either 2 or 0 child nodes. Therefore, this is a full binary tree, right? I hope you have understood full binary trees. Now let us look at complete binary tree. Before going into the definition of complete binary tree, let us look at these examples and then we will clearly understand what do I mean by a complete binary tree. Let us look at this first example. Here in this I will represent a tree in the form of an array. So here tree is represented in the form of an array, and here I have given spaces for the maximum number of nodes of this binary tree, right? So in this binary tree, the left child is B, the root is A, the left child is B, and there can be another child here to the right. There I have not drawn it, but there can be another child to the right. So that is the reason I have given three spaces. Now suppose, for example, if I just put all the nodes as a form of an array, right? So first I will write A, and then, so let us say this is level 0 and this is level 1, right? First I will write down level 0, and then for level 1 I will go from left to right. So there is only one node B, that's it. So now complete binary tree is a tree where, if I represent a tree in the form of an array, and if there are no gaps in between the nodes, here as we can see there are no gaps in between A and B, that is why this is a complete binary tree. Let us look at one more example here. A, B, C. Now this is level 0 and this is level 1, and for both the levels I have written down the maximum elements in the form of an array. Now here with two levels there can only be 3 nodes, right? So here A, B and C, these are the maximum nodes. I cannot write any other node, because if I draw another node here, it does not become a binary tree. So I want a complete binary tree. Therefore the complete binary tree has to be a binary tree. That we have to make sure. Otherwise, it is waste doing this, right? So we have to make sure that a complete binary tree is a binary tree. So here I have written down A, B, C, and there are no gaps in between A, B and C. Therefore this is also a complete binary tree. Now let us look at this tree. Here I have 0, 1, 2 levels, which means that I have 3 levels. For 3 levels, the maximum number of nodes are 7. As you can see, A, B, C, 1, 2, 3. If I have something to the left, right, that would be 4, right? This is 5, D is 5. If I have something to the left here, something to the right, 6 and 7, right? So maximum number of nodes are 7 nodes. So that is the reason I have given 7 spaces here in this area. 1, 2, 3, 4, 5, 6, 7. If you write down the indexes, index starts from 0. So 1, 2, 3, 4, 5 and 6. So there are 7 elements here. I have written down the maximum number of elements in the form of an array. Now let us write these nodes in the form of an array, right? A, then I say B. So after A, I go from left to right in level 1 here. A, B, C, and from here left to right. So while going from left to right, there is a gap here, right? So therefore I will leave a gap here, and then I will write D, and then there are 2 gaps here, right? So I will leave 2 gaps here. Now it doesn't matter if there are gaps after the last node has been inserted. It does not matter, but we don't want to have gaps in between the nodes. Here there are gaps in between the nodes. There is a gap in between the nodes. Therefore this is not a complete binary tree. I hope you have understood this, right? Now let us look at this. Here level 0, level 1, level 2, the maximum number of nodes are 7. Therefore let us fill it out. A for level 0, for level 1 I go from left to right. B, C, for level 2, D, E, F, G. So I have filled out all the elements, and you can see there are no gaps in between the nodes. Therefore this is a complete binary tree. Right? Let us look at this example. Now we have 4 levels: 0th level, 1st level, 2nd level and 3rd level. Therefore the total number of levels are 4, right? And we will try to fill out these elements. So I'll say here A, then I'll fill from left to right B, C, then I'll fill from left to right here. So once okay, let us stop here. So I have filled level 0, then I have filled level 1, right, B and C, right. Level 1 contains B and C, that's it. Now level 2 contains D, E, and I am missing these two elements left and right. Therefore I will leave two gaps here, and then I will go to level, as you can see here, I'll go to level 3 here. I will leave two gaps. These two gaps I will leave completely. I will go to level 3 here. These two gaps I will leave. I'll go to level 3. I'll fill out F, G, right, F, G. Now here also two elements are missing, so I will leave two gaps here, right. I'll leave two gaps here, and then if there was a node here, there should have been two elements here. Therefore I will leave again two gaps here, right. And if there was a node here, there would have been two elements. Therefore I will leave these two gap here, right. Now as you can observe this array here, it doesn't matter if there are all these gaps, right. It doesn't matter if there are continuous gaps after the last node. So again I repeat, it doesn't matter if there are gaps, continuous gaps after the last node. It doesn't matter if there are continuous gaps after the last node. What is the last node here? G. It doesn't matter if there are continuous gaps after the last node. All we do not want is that there should be, there should not be any gaps in between the nodes. Here there are gaps in between the nodes. As you can see, there is a gap, there is a two space or a two element gap between E and F. So if there are gaps between the nodes, then it is not a complete binary tree. It is not a complete binary tree. I hope you have understood this point very, very clearly. So complete binary trees will be useful in min heaps and max heaps. Perfect binary tree. A perfect binary tree is a tree in which each node has exactly two children, right? So each node has exactly two children. If it has a single child, and then it is not a perfect binary tree. And all leaf nodes are at the same level. So let us check this example, and then we will go back to the perfect binary tree, right? So here in perfect binary tree, we can see that right, A has exactly two children. And all leaf nodes should be at the same level. Here you can see B and C are at level 1. If this is level 0, B and C are at level 1. Therefore all nodes except the leaf nodes should have exactly two child nodes, and all the leaf nodes should be at the same level, right? Let us see this. This is a perfect binary tree. Let us look at the second example here. So here A has two child nodes. Okay, great. B has two child nodes. Great. Till now it is fine. But here we can see C does not have any child nodes, right? C does not have any child nodes. So C does not have any child nodes, and D, E and C is a leaf node. C is a leaf node. D and E are also leaf nodes. So the leaf nodes are not at the same level. So there are two conditions. Every node except all the nodes except the leaf nodes should have two child nodes, and the leaf nodes should be at the same level. Here the leaf nodes are not at the same level. Therefore this is not a perfect binary tree. This is not a perfect binary tree. Here we can see A has two child nodes, B has two child nodes, C has two child nodes, and all the leaf nodes are at the same level. Therefore this is a perfect binary tree. So a perfect binary tree is a tree in which each node has exactly two children, and all the leaf nodes are at the same level. All the leaf nodes are at the same level. So suppose here in this example, if I draw like this, F. Is this a perfect binary tree? Let us check now, right? So here A has two child nodes, B has two child nodes, but C has only one child node. So whenever you see this, so but the point is here all leaf nodes are at the same level. So I am not saying here or, I am saying here and, which means that each node should have exactly two children and all leaf nodes should be at the same level. Here the first condition is missing, right? This node E has only one child node, therefore this is not a perfect binary tree, right? I hope you have understood this lecture. We have seen binary trees, full binary tree, and okay, we have seen complete binary tree and perfect binary tree. We have seen all these types of binary trees, right? I hope you have understood this lecture. Thank you for watching.